Hello. Good afternoon. How's everybody? Hey, how are you, Jorge? I'm sorry, I was,
Not up.
yeah, how are you? Um, I was so carried away with, something, I was, when I do something, when I focus, I get so immersed, and I just don't, sense the passage of time.
Good afternoon, Professor.
How are you, Eva? How are you? I
I'm good.
thought
How
I
are you?
good, good. I thought I still had time, but it turned out it was already. Uh, so it's 2:11 now, like 2:13. Um, so let me share my screen with you. Um, so
Good evening, Professor. My bad.
hey, how are you? I'm sorry, I couldn't see who it was.
It was Peter. It was Peter.
Yeah, hi, Peter. Peter, I'm sorry about that. Um, as I said, I got so carried away. I was completing this table for tonight, and it took some time. So let me just make sure I save that file. And all right. And where was I? So in our last class, let me just quickly check where we were in our last class. It's 1400. Takes so much time. All righty. It's easier this way. I mean, I can play it from uh, YouTube.
Good afternoon, everyone.
Here I can fast forward like 2 times.
Post this. Missing entire missing 25.
Okay, this was.
Within the range, for example, even if, and also as for the return quiz to and final, and I can tell you from the day one.
Choose not to get the vaccine, so they can't upload it. Does that mean they're just doomed?
Yeah, they are. As in person, right? For being held.
At this point, the way I feel like I would.
To show the. I can't see any face or any reaction or response.
All righty. So here, yeah, looks like we've completed everything about the future value of annuity. So now we're moving on to the present value of annuity. So if there is future value of annuity, there should be present value of annuity. Now, but it's not the counterpart to, in other words, in a single cash flow model, right? Present value is the other end of the future value, and they are like opposites or counterparts to each other. But actually, in annuities, present value of annuity and future value of annuity are not the counterparts. They are not at opposite ends, right? Why? Because the opposite end of the or the counterpart of the future value of annuities are all the payments, and so are the payments to the present value of annuities. In other words, if you solve future value of annuity in reverse, then you must arrive at payment. And if you solve it for with payment given, if you solve it in reverse, then you should arrive at future value of annuity. On the other hand, also in the present value of annuity problem, the other end of the payment is the present value. Okay, present value of annuities. And if you solve present value of annuity in reverse, then you should arrive at the payment, those annuity payments. So, present value of annuities and future value of annuities are not the opposite. They are not the counterparts. Okay, I mean you can still call them counterparts because in terms of payment and payment is always in the payment is the future cash flow. So as opposed to the future cash flow, you can have either present value of those annuities or the future value of those annuities. So in concept, the present value of annuities can be summed up this way. This is ordinary annuity, right? Because ordinary annuities, the payments are made at the end of the year, right? So in this example, think about it. At the end of year 1, at the end of year 2, at the end of year 3, 4, 5, it's all future cash flows, right? Future cash flows. We want to know what's the present value of all of them, right? That's the present value of annuity. As opposed to that, future value of annuity is also future cash flow, right? All the annuities are basically future cash flow, but we want to know the future end of it, right? So this is something that students most often get confused about. They think they cannot distinguish between the present value of annuities and future value of annuities that easily. And even in present value of annuity problem, they think it is future value of annuity, future value problem. Why? Because the cash flows are in the future. But just because the cash flows are in the future, it doesn't have to be a future value problem, right? If you already know even in single cash flow model, if you already know the future value, right, target future value, right, the cash flow is in the future, but what we want to know is the present value of that, right? So it's the question of, in other words, it's really the question of or issue of reading comprehension. And some students have a very poor reading comprehension. They can read, but they don't comprehend. Why can't they comprehend? Because they can't analyze. They never thought about it analytically. They just read like a machine. They just, it's just like, these days we can, the browsers can read, right? Web browsers can read. So you activate reading out loud, it reads. But does the machine, when computer reads it, does it understand? It's just mechanical. There's no comprehension there. Comprehension is for humans to make. And then some students think they can understand it because they can read it. But they are doing nothing but what a computer does. They just read it, but they poorly comprehend it. Why? Because they never were trained to think analytically. So analytical reasoning is very important. And so we're going to get to that later because how do you know if it is about if you read a problem, but the problem is asking for how much, the problem, the narrative is asking you whether it is for present value of annuity or future value of annuity. It doesn't say straightforward what's the future value of annuity. It doesn't say straightforward like that. But there are all the clues in the problem. Well, for example, think about it. Mr. X wants to retire. Mr. X wants to retire in 20 years. Right? And then so 20 years from now, it will be, let's say this year is 2020. 20 years from now, it's going to be 2040. Right? But he will retire 20 years later. And think about it. When you retire, you will need money. So he wants to, he wants to he wants to purchase a pension fund that will pay him $2,000 every month, right, for 20 years after retiring. So then, think about it. You have 20-year timeline now to retirement, right? Because he's going to retire in 20 years. And then you have another 20-year timeline after the retirement. So the question is, then how much money? So if he wants $2,000 monthly from this pension fund, right, for 20 years after his retirement, what should be the how much does he have to pay today, right, to purchase such a retirement plan? Now think about it. This requires reading comprehension. This really requires, analytical thinking, right? Why? First of all, this is a two-part problem if you think about it. First, he needs $2,000 every month for the next 20 years. I mean, after he retires. That's not 20 years from now. It's going to be 20 years from now. You understand? Then $2,000 every month for 20 years means there will be 240 payments of $2,000. Then what should be the such an annuity? What should such an annuity be worth? What should such an annuity be worth? Worth at what point? At 20 years from now. You understand? As of 2040, right? As of 2040, when he retires, his retirement begins, and his annuity payment begins. As of that point, what is the price of such an annuity at the time? Well, then that's present value of annuity problem. So a lot of you might get confused. Why is it present value? Isn't it 20 years into the? Isn't it 20 years from now? So why is it present value? No, present value means present value at time 20. Present value at time 20. In other words, the annuity payment starts from year 20. So that year 20 is time 0 for that annuity. Does that make sense? In other words, the first month of 2040 and the annuity you receive at the end of January of 2040, right? That's the first annuity payment. And so we need to find the present value of all those annuities as of time zero, which is the beginning of January of 2040. So it's a present value problem. You understand? Present value of annuity problem. And then, if you find the present value of that, then to purchase such an annuity plan, purchase such an annuity plan, you purchase it today. You're purchasing it today. You know, in other words, today is then time zero, January 1st of 2020. You're purchasing it today. Okay, 2021 is fine because beginning of 2021 is the end of 2020. You're purchasing it, so then we have found the present value of such an annuity, but that present value is as of beginning of 2040. So then, to buy today, you need to find the present value of that present value of annuity. Make sense? Once you find the present value of annuity starting at 2040, but then you have to discount it back to 2020 or beginning of 2021, right? So this is analytical thinking, but a lot of students just can't carry on that thought, right? That analytical, they cannot carry on that analytical thinking. Another thing, as I said, all the cash flows are basically in the future, right? All the cash flows are basically in the future. And so suppose, I'm not going to use any more examples like that, but because we cannot spend all the time. So this is ordinary annuity because it's making a payment at the end of it, and this is annuity due because the payments are at the beginning of the year, and the difference is one more compounding. Exactly, one more compounding. Why? Think about it. You might say, and it's the same thing as saying one less compounding. One less discounting. One less discounting. You might say, where is compounding? Isn't it all discounting? Yes, it's all discounting. And so, think about it. In ordinary annuity, you have, the last payment is discounted 5 times. Fourth payment discounted 4 times, and so on. The first payment discounted once. But in annuity due, the 5th payment, the last payment, is discounted only 4 times, right? 4th payment discounted 3 times, and so on. The first payment doesn't get discounted at all because it's at time zero. It's already in present value. And so you might say, isn't it being discounted? Yeah, it's discounted by 1.05, 1 plus r raised to 0. And remember, anything raised to 0 is just 1. That means 0 discounting, right? So then, what's the difference between the two? Annuity dues have 1 less discounting. 1 less discounting. Right? That's the difference. But I said already, is the same thing as one more compounding. Why? This is also logical thinking and analytical thinking. But logical, and a lot of students don't get it. Because logical thinking and analytical thinking, you're not born with that. Right? It is only fostered through a lot of training, rigorous training. Unless you're a genius, you're not born with that. But at your age, if you're 20-somethings, you're still like a baby in analytical thinking because you have never been trained. Why? Through, in the US, the public education system is such a mess. K through 12, they never get trained rigorously. The mental rigor is not, it's all foreign concept. They barely write and read, barely do basic math. K through 12. Why? Because nothing was enforced. Something has to be enforced. There's no other way to make your brain work. Otherwise, all K through 12, everything is liberal arts. Everything is liberal arts. And liberal arts are easy. It's like, piece of cake. Everything is sweet stuff. Everything is just, nothing is stressful. Nothing is putting you through a rigor. But the only thing that puts you through rigor is math. Math requires rigorous thought frame. But the babies with only sweet tooth for sweet things refuse anything hard, anything punishing, or anything rigorous, anything strenuous, anything strict. They all refuse. If they can choose, they only want options, from the menu box. They only want options, easy options. And if they can avoid hard courses, they can just avoid hard courses. And that's the problem. That's the reason why even at the age of 20-something, a lot of people, a lot of students are very poor in rigorous thinking or tenacious reading comprehension, tenacious thinking, because reading comprehension requires tenacious, rigorous and tenacious thinking. But that's all lost. That's never been enforced. That was never enforced during, throughout K through 12. And just, everything is just pampering. It's all just, oh, you're wonderful. Just pat on the back. Oh, you're wonderful. But, you would be wonderful if you are held to your responsibility, and if you pursue the perfection, if you pursue the completion of work, and hold yourself to responsibility, and if you've been trained like that, you're wonderful. But without achieving anything, accomplishing anything, without holding themselves up, to responsibility, they just still pamper, and they are getting pampered and getting pat on the back, and just always hear things like "you are wonderful." And that's the problem of the U.S. public education system. Because it's only celebrating easy things, Be happy. Feel good about what you are, who you are, even without accomplishing anything. And the accomplishment they are talking about is like baby accomplishments, even at the age of 20 something. And the accomplishment of people at the age of 20 something is like the level of, of eighth graders. So that's the problem. That's the problem. Okay, so I kind of digressed too much. So let me explain to you why I mean what I'm saying. Why I'm saying that it's the same thing as one less discounting is the same thing as one more compounding, and this requires logical thinking. Why? So let me. Oh my goodness. So let's say we'll know. What is x to the negative third? Anybody can anybody tell me what is x to the negative third? Mm-hmm. X to the negative third power. Anyone? Come on. No one? Hmm? This is easy. This is something we have, done in the properties of exponents. Hmm? Can anyone? What is x raised to the negative third power? How many people do I have here? I have 9 people. Ashley, are you there, Ashley? Edgar, are you there, Edgar? Edgar? Eva, are you there, Eva?
Yes, I'm here.
Yeah, hi, Eva. So can you tell me what x raised to the negative third power is?
It's X.
X? No, it's x to the negative third. It cannot be the same thing as x. Right? Jiaming, are you there, Jiaming? Jiaming? Jorge. Jorge, are you there? Valencia, Jorge? Mamadou, are you there, Mamadou?
It's equal to M, sir. Professor.
I'm sorry, say that again.
It's equal to M.
M?
M.
M. Where did M come from? Suddenly, out of blue, where did M come from? Hmm? Jorge. Okay, you are there, so can you answer that? Jorge, can you answer it? What is x to the negative 3? Hmm? Mamadou, are you there? Mohammed, are you there? 9? Why suddenly 9? I mean, where did the number come from? 9?
Is it 3?
3? Where did the number come from? Look,
Professor.
9 is, you probably thought 9 because, you thought about 3 squared, but that's 3 squared. 3 squared is 9. 3 times 3. But this is x to the negative third. I mean, if x is if it is x squared, and if x squared is 9, then you can say x is 3. But there was no number here. There's no number here. Think about it. And x squared and x to the third are totally different things. Because if x is 3, x squared will be, oh yeah, who said that? Jiaming? Yeah, you're right. Did everyone see what Jiaming wrote there? It's x over x to the third, right? It's x over 1 over x to the third. You should know that we did this before, right? In the properties of exponents. Negative exponents are reciprocal, right? Negative exponents are reciprocals. Okay, Jeremy, you get you get 0.25. You're getting 0.25 for that. Okay. So and I'm not asking for what is x. I didn't ask for what is x. I simply asked, what is, x to the -3? What is it, this, equal to? And without any number given, the only thing you can think about is, another way of expressing it. Now, but let's say we multiplied to this. We multiplied x to this, right? So it's not equal anymore, because when you multiply this thing by x, it's not equal. So I just changed it to an arrow sign, right? So who can give me the answer? 1 over, so x to the -3 times x, or 1 over x to the third power times x. What's it going to be? In other words, it's the same thing as x to the -3 times x. So then what should this become? Anyone? Okay. Peter. Peter. Oh, Jiaming, you already got it right. Yeah, Jiaming, you got another 0.25. Yeah. Did everyone see that? Jiaming said 1 over x squared. Yes, of course. Why? Because it will cancel with one of the x's. Okay? In other words, geez, I already crossed it out. It reduces this to 2. So in other words, why? Because x to the third power is x times 1 over x times x times x. And then if you multiply it by x, if you multiply it by x, it cancels out with one of the x's in the denominator, right? So then it becomes one over x squared, right? Also, you know the rule the product rule. Now this is x to the negative third times x to the 1. Isn't it right? X to 1 is itself, right? X raised to 1, it's just itself. And then think about it. The product rule says, if the base is the same and the numbers are numbers, with exponents, and the base is the same, you simply, and if they are multiplied, you add them, and this is what? Then this becomes, you add the exponents, this becomes x to the negative 2, which is 1 over x squared, right? And why did I suddenly show this? It's because I said, oh, back there. I said one more compounding is the same thing as one less discounting. Look, this is, this is discounting, right? It's like, it's like 1 over 1 plus r cubed, right? Then you multiply it by 1 plus r. This is discounting, this is compounding. By compounding, this becomes 1 over 1 plus r squared. So from 1 plus r cubed, it becomes 1 plus r squared. So one less compounding, right? Does it make sense, everyone? It's one less compounding. I'm having a headache because as I speak, I don't know why. It must be my blood pressure, as if my cranium is, banging on. It's like my brain is, banging against my cranium. And your blood pressure rises when you have to stressfully speak, right? And I'm stressing this, so much. So everyone is clear about that. One less compounding is the same thing as one more compounding. Right? Makes sense? Nobody's responding. This is a disaster. So, okay. Now let's. So that's what I'm talking about. Annuity dues have one less compounding than, one less discounting than ordinary annuities. And one less compounding is the same thing as one less discounting is the same thing as one more compounding. Okay? So let's think about, and think about it. Most, as I said, and most of the loans if you take out a loan, right? If you take out a loan, the way you paid back, is annuities, right? Suppose you took out a mortgage loan. Suppose you took out a mortgage loan, $500,000. You took out $500,000, and 30-year mortgage. The mortgage term of the mortgage loan is usually 15 years, 20 years, 25 years, or 30 years. So you took out 30-year loan. Does that mean the bank is waiting for you to come up? The bank is waiting 30 years for you to come up with the one big lump sum future value? Huh? You understand what I'm saying? If you take out a mortgage loan, right, 30-year mortgage, there's no lender, no bank that waits 30 years for you to come up with the full future value of $500,000. I mean, 500,000, yeah. Because there's too much risk. You may not be around anymore in 30 years. So what do? The minute you take out the loan, right, the payment begins from the next month. You will pay an installment, monthly installment over 30 years. And that monthly payment is comprised of principal and interest. It's comprised of principal and interest. Right? So that's why present value of annuity is the right model, right? Annuity is the right model for most of the loans. Loans fit exactly the present value of annuities. Why is it present value of annuities? Why isn't it future value? Why is it present value of annuities? Because think about it. The loan, you took out the mortgage, $500,000 mortgage, right? And then think about it. The $500,000 mortgage is your principal, right? And you're making the payment, monthly payments, to pay off that principal. You might wonder, what about the interest? Isn't there interest? I already said interest is included in the monthly payments. Isn't it right? Your monthly payment is comprised of principal and interest. So think about it. These payments are cash flows in the future. These payments are the cash flows in the future. So you are basically, making payments in the future in, monthly installments every month until the end of the 360 months, right? So the point is, if those cash flows are basically in the future, then including interest and principal, then the present value of all of them must exactly add up to your principal amount of loan that you took out, which is 500K. Make sense? So the point is, are you with me? Are you with me or not? Are you with me or are you with me or against me? That's what George W. Bush said. Okay. Someone was trying to say, huh? Are you with me? I heard some microphone. But what I'm asking, are you with me or against me? I'm asking, are you with me? Do you follow? Everyone is with me. Nobody's saying anything. Nobody's responding. This is a disaster. Right? Let me. So you see what I'm saying is, you took out the loan of right. What I'm saying here. The principal is 500K, right? And the question is, equal sign is so hard to make. And now think about it. The sum of all the present values of those annuity payments, right? All the present value of those annuity payments must be equal to the principal of the loan. If you, when the discount rate is, when discounted by the interest rate of the loan, right? But sometimes it can be like this. The present value of all those annuities can be less than the principal, or it can be greater than the principal. How? Look, if you discount it by the interest rate of the loan, right? It will always be equal to. The principal. Okay. Why? Because that was how it was calculated. When they, at the time of the loan, right? At the time of the loan, the bank calculated the monthly payments by discounting it with the interest rate on the loan. So it is supposed to be equal to the principal. That way, all those future cash flows, present value of all of that, being equal to the principal, and that then makes the loan fully recovered, right? But then over time, market interest rate changes. Okay, you understand? Interest rate on the loan and the market interest rates are two different things. Why? Interest rate on the loan is fixed, right? You lock into, when you get a loan, when you take out a loan from the bank, you want to get the best rate. Why? Best rate means, the lowest possible interest rate. And to pay, on during the, time during the term of the loan. You want to lock into the lowest possible rate. And of course, depending on your credit score, and depending on other factors, you may not get the lowest rate. But everybody wants to lock into the lowest possible rate, and generally you'll get whatever is the best available rate, given your credit scores and other factors, right? And that interest rate is fixed. throughout the, that's because your interest rate of your interest payment, right? It doesn't change over the life of the loan, right? It's fixed. Of course, sometimes there are flexible rate loan, flexible rate, or adjustable rate mortgage, adjustable rate. That means, you know, your interest rate will fluctuate. It will change with the market interest rate. And think about it. Market interest rate changes constantly. Isn't that right? Because if your loan mortgage is for 30 years, over 30 years, how many times the market, the going rate in the market will change? Going rate in the market will change, you know, at least like dozen times over 30 years. It will change at least dozen times over 30, right? So so that is different from your, you know, interest rate on the loan, right? Your interest rate on the loan is fixed, but the going rate in the market will tend to fluctuate. So think about it. If there can be two things that can happen. If market interest rate goes up, those present value of annuities will go down, right? Some of those annuities, present value of annuities, will go down, of course. Because this market interest rate is the discount rate. It is being used as the discount rate. And if the discount rate goes up, that means denominator is going up. If the denominator goes up, the whole fraction goes down. That goes without saying. On the other hand, if the market rate goes down, present value of those annuities will go up, right? So that's why, you know, sometimes, you know, present value of annuities can be less than the principal, right? Or the present value of annuities can be greater than the principal. But what is the implication? If the present value of annuities are less than the principal, then you are paying less than what you owe, right? You are paying less than what you owe. If it is the opposite, you're paying more than what you owe, right? You understand? It's just like, you know, just like inflation. When inflation goes up, when inflation is high, it's time to pay back, because in real terms, right, in real sense, effectively, you are paying less than what you owe, because inflation has eroded purchasing power of money. You're paying back the same $10,000, but effectively, that since the purchasing power of $10,000 is lower now, right? So, but of course, you know, if you use if you use the original interest rate on your loan, which is fixed, right? If you use it as the discount rate, it will always be equal to principal. From the bank's perspective, it's important to recover the loan, right? And based on the original interest rate, the fixed rate they set on your loan, they will get their interest, principal and interest back. They recover everything. But if this is the case, then you are, paying less than what you owe. If interest rate goes up, if interest rate goes down, you're paying more than what you owe. It just happens. I mean, there's nothing you as the rate fluctuates over time. That's what is called, interest rate risk, or maturity risk, or the price risk. Okay. Well, that's all the time we have today, I believe. We have a little more time. Yeah, we have a little more time, but that's not enough time to do our examples. But let me show you the examples. There are two examples. The first one is a lottery. The second one is a loan, right? So second one is exactly, a very typical case of financing. It was borrowing from the bank. The first one is not very realistic, because lottery is, if you don't, lottery is not something you win every day, right? Lottery is not something that can happen to your life that often. I mean, it may happen once in your life. You would be very lucky, but it never happened. It has never happened in my life. But I just still keep hoping. But we're gonna go into these examples in the next class, and that's all the time we have. So, any questions so far? Any questions? Any questions? Anybody? Any questions? No. I hear
No,
nothing.
Professor, no questions.
Okay, all right. Thank you, Eva. You're the only one. You're the only one, at least, makes this, gesture of, sign of, sign of life. There is no only single sign of life. Other people are all like, very quiet, like dead. Almost, no sign of, no sign of vitality. Alrighty, so if you have no more questions, then we'll call it a day here. I will see you guys next Tuesday. And don't forget, the quiz 2 starts tomorrow. Alright. Alrighty, have a great afternoon, everyone.
You too, Professor.
Alright, thank you, Eva. Take care, everyone. I will stop sharing, stop recording.